A box is placed on a rough plane inclined at 10 degrees to the horizontal. The total mass of the box and its contents when full is 60 kilograms. The box can be moved up the plane with constant velocity by a force of magnitude p newtons parallel to the slope. When the box is empty, it has a mass of 40 kilograms and can be moved down the plane with constant velocity by a force of magnitude q newtons. Q acts in the opposite direction to P, and P is equal to 5Q. A. Show that the value of the coefficient of friction between the box and the plane is 0.327 to 3 significant figures.
Hello everyone, and I hope you enjoyed my last video on the inclined plane. Here we have another inclined plane problem on our hand. Just when we get to the end of the exam paper, we turn the page, and yet we have another box sliding down another inclined plane, making an absolute nuisance of itself. So how do we proceed? Well, this is a question of forces. Question of forces, the first thing we have to do is draw all of the forces acting on our box. So we do a quick sketch, and we put our forces on, and there are 4 forces. Now I've used the subscript 1 here to indicate there's 2 parts of the problem. There's also the part of the problem where the box is going down the slope. That's indicated by the subscript 2, as you'll see later. So, 4 forces. First force, the weight of the block, M1 times G, that's always acting vertically downwards. Always acts vertically downwards, irrespective of the angle of the slope. There's the force P pulling the box up the slope. There's the force mu N1. That's the force of friction acting on the box down the slope. As you can notice, I've drawn these 2 vectors at with different lengths, and that's quite significant. And also there's a normal force acting on the box. That's the force the slope exerts on the block. And that is our starting point. So how do we proceed from there? Well, we notice in the question that we're told the box is going up and down the slope with a constant velocity. So if it's going up and down the slope with a constant velocity, all the forces, Newton's laws of motion tell us all of the forces have to be balanced in all directions. The directions we shall choose will be the directions up and down the slope and perpendicular to the slope. And if you look, we're told these forces are balanced, but the force pulling the block up the slope is longer, deliberately drawn longer than the force of friction down the slope. So those 2 forces can't be balanced. However, there's a component of the body's weight that has to be resolved along the slope and perpendicular to the slope. And when we put those components in, we see that we do have a balanced situation on our hands, and then we can proceed with the problem. So the following clip shows how to do this problem. Now the problem's in 2 parts. We've got the box moving up the slope, then we've got the box moving down the slope. So that makes 2 different force diagrams. And what I've done in the clip, I've done both situations side by side so you can contrast and compare. You might find that a useful exercise. A couple of things I'd like to point out though. First of all, the force of friction is a force that opposes motion. So if the box is moving up the slope, the force of friction is down the slope and has to be signed a negative value. If the box is moving down the slope, then the force of friction is up the slope and has to be assigned a positive value. So when we're adding up all our forces, we have to remember to put in the correct sign, otherwise we'll get it wrong. Now, remember we're adding up forces here. So when you see a minus sign, what it really means is force A minus force B really means force A plus negative force B, which is the same as A minus B. But that's really what's happening. Now, you've got to remember we're adding up vectors here. These are not scalars. So if we've got a vector, for example, of negative 6 newtons, a force vector of negative 6 newtons isn't 12 units less than a force of positive 6 newtons. It's simply 6 newtons in the opposite direction. That's all that means. Unlike scalars, if we've got a scalar like energy, for example, and we've got an energy value of negative 6 joules, that is 12 units less than positive 6 joules, because that's a scalar. After we've written down our force expression, after that it's mathematical manipulation, simultaneous equations to get to the right answer. I'm not saying too much about that, but if you're not sure about what it is, you ought to study it and understand how we go from one line to the next line. Not too difficult, but some you should nevertheless know. The box is now attached to a light and extensible cable. Starting from rest, the box is pulled up the plane by the cable. The tension in the cable is of magnitude 300 newtons and acts parallel to the slope. After 10 seconds the cable snaps and the box continues to move until it comes to rest. B. Calculate the total distance the box travels up the plane. And that's for 6 marks. So how do we proceed with this question then? We're asked to find the distance. And the distance is always an average speed times the time. So how do we find the average speed? How do we find the time? Well, we have another force question on our hands, except the forces along the slope don't add up to 0 because they are not balanced. They are unbalanced in this case. The forces add up to m times a. Using the second law, whether the box is speeding up or whether the box is slowing down after the cable breaks. They will always add up to m times a, although we'll get 2 different accelerations, one for speeding up the slope and one for slowing down going up the slope. But the accelerations shall be constant because the forces are constant. As the accelerations are constant, the body is speeding up at a constant rate and slowing down at a constant rate. So we can construct a speed time graph like the one shown here. Now, a graph like this starts at 0 and ends at 0. The average speed will always be exactly half the final speed. Exactly half the final speed. Multiply that by the total time elapsed. We have our answer. So we can use F equals ma, the sum of the forces equal to m times a, to find out the acceleration as it speeds up, and use v is equal to u plus at to find the final velocity, which u is equal to 0. And similarly, when we have a negative acceleration as the box slows down, again we can use v is equal to u plus at to find the time it took for the body to slow down, where v in this case is equal to 0, the final velocity. Now if you notice, I'm using speed and velocity interchangeably here, but that's okay because the direction of the box isn't changing. So these things can be used interchangeably. We need to be careful though.